Welcome to Unit 1, Lesson 8. This is the second video. We are continuing the first video for Lesson 8, and we left off right here with example number 2 for completing the squares. Now, let's do it. All right, I am just going to erase this right here. And I am going to, we're dealing with problems where this is not a 1 in front of our x squared. We always want it to be a 1. So what we're going to do is we're going to divide everything by 4. Okay? We're going to divide every single term by 4. So now, x squared plus, oh, that's nice, 1x. Okay, Visca, we have a fraction. That's fine. We're in Algebra 2. We can deal with fractions. All right? And 0 divided by 4, well, that's still 0. Now, same rules apply. If you're not familiar with the rules, go back and watch Part 1 of Unit 1, Lesson 8, because that's where we discuss the rules. What I want to do now is get everything without an x, okay, our constant. I want to get that over to the other side of the equal sign. So I add 5/4 to both sides. Now, I have x squared plus 1x equals 5/4. No big deal. It's cool. We're cool. Everything's cool. We're still going. Don't freak out. We have a fraction. That's fine. Now, again, this is the brain trust. If you don't know this step, you better go back and know this step and practice this step, because I take my b value. That's whatever's in front of the x. Okay, it's a 1. I cut it in half, and then I square it. Okay? So, I deal with whatever's in parentheses first, okay? Like for the problem over here, I took 2 divided by 2 and got 1. Then I squared it to get 1. Okay, simple. Here, well, I can't do anything to my 1/2, so it stays 1/2. And if I square 1/2, I have to square the top and the bottom of the fraction. So 1 squared is 1 over 2 squared, it's 4. This is the value that I'm adding to both sides. Add 1/4, and then I add 1/4 to this side as well. Okay. Let's write what we currently have. We have x squared plus x plus 1/4 equals, now if I have 5/4 and I add 1/4, that will give me 6/4. All right, that's nice. I'm just going to leave it like that. But mister, that reduces. It does reduce to 3/2. But let's leave it 6/4 for right now. Okay? And we're going to keep working. This is a perfect square. We are completing the square, and we just completed the square right here. This turns out to be a perfect square. X, what goes in the parentheses here, is the same thing that's in parentheses here before you square it. It's a positive 1/2 equals 6/4. All right? Now I just solve for x algebraically. Just like part 1 of this lesson, okay, the opposite of squaring something is taking the square root. What I do to one side, I have to do to the other. The square and square root cancel, so I've got x plus 1/2 equals. Now, my friends, as we discussed earlier, a fraction under the radical is the same thing as radical top over radical bottom. So I will leave this the square root of 6, and the square root of 4 is 2. That's so nice that it works out. So that equals the square root of 6 over 2 plus and minus. Don't forget, I need two answers because my biggest exponent is a 2. Now, the last thing I need to do, and we're almost done, the last thing I need to do is I need to get my 1/2 over. So I'm going to subtract 1/2 from both sides, and I will write it as such. X equals negative 1/2 plus or minus radical 6 over 2. If you want to combine those, because both both denominators are the same. When I add or subtract fractions, the bottoms have to be the same. All right? What I have here is a good answer. But if I wanted to combine my fractions, or if this is multiple choice, it may look like negative 1 plus or minus the square root of 6 all over 2. It might look like that. Okay, so I just want to get you guys familiar with the way it looks. Okay, so if you want to go ahead and try these practice problems right now, go ahead and do that. And I will do them right now. So if you want to pause the video, pause it. Here I go. Number 1. What value needs to be placed in the box to complete the square? All right. So what is the brain trust? What do I do to complete the square? I take my b value, negative 12. I cut it in half, and then I square it. So that's negative 6 squared, which is a positive 36. I would have to have 36 here to complete the square, and that's choice 2. All right. The second problem. Complete the square. Perfect. I get my constant alone on one side. So I have x squared plus 8x equals 15. Brain trust time. Get the brains out. I take my 8. I cut it in half. And then I square it. That's 4 squared. And that's 16. So I'm going to add 16 to both sides. So I have x squared plus 8x plus 16 equals 31. All right. We now have a perfect square. What goes in with my x in this perfect square? What goes in parentheses here is what is in parentheses here. That's a positive 4. And now I'm just going to algebraically solve this. Take the square root of this side and this side. Let's do this in purple. My square and my square root cancel, so I have x plus 4 equals the square root of 31. But let us not forget the biggest exponent, or my degree, is 2, so I should have two answers, a positive and negative 31. Now I just subtract 4 from both sides. X equals negative 4 plus or minus the square root of 31. Very good, very good, very good. Not too shabby. I'm getting pretty good at this stuff. Solve by completing the square. Okay, number 3. They did us a solid here. They already put my constant on the right side of the equal sign. So I don't have to do step 1. I start with step 2, which is the brain trust, the brainchild, if you will. My b value, negative 6. I cut it in half, and I square it. That's the same as saying negative 3 squared, because half of negative 6 is negative 3. And if I square negative 3, I get 9. So I am going to add 9 to both sides. X squared minus 6x plus 9 equals 7. I now have completed the square. I have a perfect square here. That is x something squared equals 7. What is in parentheses here? Goes in parentheses here. Minus 3. And now I just solve for x, like I have been this whole time. Square root both sides. My purple, yellow, I'm going to go yellow. My 2 and my square root cancel. So x minus 3 equals plus and minus radical 7. And now, we can go purple. Let's just add 3 to both sides. X equals 3 plus or minus radical 7. The more you do this, the easier it becomes. Let's go all the way up here to 4. Solve by completing the square. Not only do I have my constant on the left-hand side, I do not have a 1 in front of my x squared. So I need to make it a 1, so I'm just going to divide everything by 2. X squared plus 2 goes into 18 9 times plus 2 goes into 4 twice equals 0. Now I start this just like I did problem 2. Okay, I got to bring my constant over. Subtract 2, x squared plus 9x equals negative 2. Ouch! Here's what's going to happen. My b value is not a nice even number. I can't cut it in half and get a whole number. That's cool. That's fine. Okay? So I take 9. I cut it in half. Okay, I got to take my b value. And then I square it. Okay? I cannot do anything to simplify this. All right? Yes. Some people like to deal in decimals when they have fractions and call it 4.5. But with Algebra 2, more times than not, it is common for us to keep fractions. So I'm going to keep this a fraction. If I square this, I need to square the top, and I need to square the bottom. 9 squared is 81. 2 squared is 4. This is the value that I'm going to add to both sides. Plus 81 over 4 plus 81 over 4. Ooh. Now, you would think I have some work ahead of me. And I do. I do have some work ahead of me, and it's just right here. Because after I combine, all right, after I combine these two values, the rest of this is easy. All right? So let's combine those two values. If I have negative 2 plus 81 over 4, whenever I add and subtract fractions, it's really easy to do as long as the denominators are the same. So technically, below this negative 2 is 1. I would like this to be over 4, so the denominators are the same, so it will remain the same. How do I represent negative 2 over 1 to be 4? Negative 8 over 4. How did I do that? I multiplied the bottom by 4, and I multiplied the top by 4. Now I can combine those. 81 minus 8, I don't know, 73. It sounds right to me. This is what's going to happen when I combine these two, and we'll go right here. 73 over 4. All right. I said that's going to be the worst part, and it is. And you're looking at me while you're hearing me, and you're saying, Visca, no way, because now I need to get a perfect square here. But that's easy because we completed the square, and we already have that number. That's a 3, not a 2. That number is already in our face. What is in parentheses here? That's a positive 9/2 goes in parentheses here every single flippin' time. All right? And now we just solve. I take the square root of both sides. Ba-ba-boo, ba-ba-boo. And then I notice that square and square root cancels. That's why I take the square root. And I have x plus 9/2 equals, oh, this is nice. How come? Because anytime I have a fraction under a radical, the radical is a square root, That's like saying square root of the top over square root of the bottom, and the square root of the bottom is a nice whole number. The square root of 4 is 2. Don't forget plus or minus square root of 73 over 2. My last step, I just subtract 9 halves. Subtract 9 halves. Now this problem has some longevity. Okay, this goes away. So I got x equals negative 9 halves plus or minus the square root of 73 over 2. And this is fine. But again, if this was multiple choice, those bottoms are the same. I can combine them. I'll put everything over 2. It's negative 9 plus or minus the square root of 73. Whew. That had a little bit of girth to it. And how come? Well, 2 reasons. One, we had to get rid of the number in front of x squared. We wanted to make it a 1. So we had to divide everything by 2. Then we noticed, oh my goodness gracious, our b value is odd. So we can't cut it in half to get a nice whole number. It's going to remain a fraction. And we had to deal with this. Then, when I combined my 2 fractions here, well, actually, my whole number, negative 2, and my fraction, I had to kind of simplify everything to get purple. Let's see how purple looks. To get this. Oh, yeah, no, I can't see that. That's terrible. Let's go back to yellow. To get this. And that's what went here. Then, oh my goodness, look what they did to me. I realized that the square root of 4 is a nice whole number, and it's 2. And then we finished the problem. That was a very in-depth, detailed problem. If you could do that all the way through, you got this. You got this and a whole bunch more, buddy. Number 5. Holy cow, is there 6 problems? Wow, we better get moving. All right, number 5. Oh, look at them do it to us again. I want to make in front of x squared a 1. X squared plus 2x minus 7/3 equals 0. Well, I got to get my constant over, so I'm going to add 7/3 to both sides. Oh my goodness gracious. X squared plus 2x equals 7/3. This turns out nice for us. My b value, brain trust time. Take my b value, cut it in half, and square it. 2 divided by 2, that's the same thing as saying 1 squared, which is 1. I am going to add 1 to both sides. And I should know at this point that if I'm going to combine 7/3 and 1, I want to make it so that they're both fractions with a 3 in the bottom. 7/3 plus. How do I represent 1 as a fraction with a 3 in the bottom? Well, 3 over 3 is 1, isn't it? Yes, it is, Mr. Visca. You're the smartest guy ever. I know, right? So I add 7/3 plus 3/3, and I get 10/3. It's not too bad. So x squared plus 2x plus 1 equals 10/3. All right. All right. We have our perfect square here. Whatever number is in parentheses here, that's a 1. It's a positive 1. Goes there. And now it just comes time to solve. Take the square root of both sides because squaring and square root cancel. X plus 1 equals a square root of 10 over 3. That's the whole thing. Don't forget plus and minus. And now I've just got to subtract 1 from both sides. Oh, running out of space here. X equals negative 1 plus or minus a square root of 10/3. if they want you to simplify this right here, okay, and I'm going to do that right over here off to the side. If I have radical 10 thirds, that's the same thing as saying radical 10 over radical 3. I multiply the denominator by itself. It's a square root of 30 all over. Well, square root of 3 times square root of 3 is the square root of 9, which is 3. So here's a little trick. Whenever I'm multiplying square roots together and it's the same number, I can just drop the square root and it just turns into that number. Okay? So if I wanted to rewrite this, I could say -1 plus or minus radical 30 over 3. Because technically, it's not simplified if we have a square root in the denominator. They might have you do that, they might not, but I wanted to show you how it's done. Oh my goodness. Number 6. Wow, it would have been nice if I left you guys some space on this room, huh? We have no space to write anymore, so I'm going to erase that and do this over here. If I take this problem and I solve it by completing the squares, an intermediate step would be, now they're not asking us to solve it completely. I mean, we can, but they're just saying if I do solve it, I will eventually have one of these steps in there. So I'm going to begin to solve this problem until I get to one of these steps. Now, it looks like to me, right, they are waiting for us to get to a point where we can, in blue, I have this written here in blue. Before I put the purple square root and the yellow cancel, you see I have in blue there, it was x plus 1 squared equals 10 thirds or whatever. It looks like they're waiting till I get to that point before I can actually start solving for x. So that's as far as I'm going to get in this problem because that's as far as they're asking. All right. X squared. The first thing I'm going to do is I'm going to rewrite this in standard form. X squared minus 6x plus 2 equals 0. I'm going to get rid of my constant on my left side, and I've got x squared minus 6x equals -2. Brain trust time. Take my -6, cut it in half, and I square it. That's like saying -3 squared, which is 9. All right, so I'm going to add 9 to both sides. X squared minus 6x plus 9 equals 7. That is almost identical to this right here. In fact, it is. If I didn't erase the work, I could have looked at it and had the answer. Look at me go. We have a perfect square here now. It's x something squared equals 7. And the same number that goes in parentheses here is the one in parentheses here. So which one of my 4 choices has x minus 3 squared equals 7? Choice 3. We don't have to finish that problem all the way. Whew, that was a lot of work. But guess what? We did it. And if you understand it better, the more you do it, the better you'll be at it. Let's move forward. All right, we're going to change gears a little bit. We've been doing completing the square for a while. Let's talk about that other method for us to solve quadratics where we don't factor. Okay? There's factoring, there's completing the square, and there's using the quadratic formula. In case you forgot, the quadratic formula states that x equals b squared minus the square root. Yep, I'll be okay. It's been a long day. I was starting to write the discriminant, which is what we're about to talk about right now. It's -b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. But there's something nice about the quadratic formula that can help us figure out something about our answers without doing the whole thing. I am just referring to b squared minus 4ac. I'm not even talking about the square root. I'm just talking about b squared minus 4ac. This right here is known as the discriminant. Okay? And we are going to discuss that value. Okay? Now, if I figure out b squared minus 4ac, like right now I have no problem. I don't know what a is. I don't know what b is. I don't know what c is. But let's say I have a problem and I have a b value. So I would substitute it in. Ooh, I like the highlighter. And I substitute in my b value here. And I have an a value and I substitute that here. And I have a c value and I put it in here. That's going to give me a number. Okay? That number is what we call the discriminant. Whatever that number is that's underneath this radical sign right here. If I was doing the quadratic formula, whatever number is underneath the radical sign, that's what we're referring to when I talk about this right here. If I calculate that number and it turns out to be a perfect square that's bigger than 0, that's what this means. It's a perfect square and it's bigger than 0. Okay? That means I will have 2 real rational roots. All right? Now, this is going to be for reference, this chart we make here. Okay, it's going to be for reference. We'll do some problems with this afterward, but just follow me. 2 real rational roots. What is a rational number? A rational number, I'm going to put rats here to abbreviate. That's 8, -2. They're whole numbers, or they're numbers that can be represented by a fraction. 1/2. Okay, 2/5, whatever. Pi is not rational because it goes on forever. 1/2 is rational because it's 0.5. It stops. Okay? So I would get, if I were to solve this whole thing out, I should be able to get 2 real rational roots. So if I were to give you a graph here, an example of a graph. Here's -1. Here's 2. And I had a parabola that had 2 real rational roots. Well, the answers, because remember, roots are the same thing as the solution, the zeros, the roots, or the x-intercepts, where it touches the x-axis. It might touch at 1 and 2, because those are -1 and 2, excuse me, because those are real. There's 2 of them, and they're rational. All right? What happens if my discriminant, okay? What happens if my discriminant, this value here, turns out to be bigger than 0, but it's not a perfect square? Okay? And by perfect square, I mean 1 is a perfect square, 4, 9, 16, 25, etc. Those are perfect squares. Those are numbers that if I take the square root of them, they give me a whole number. All right? So what if I'm greater than 0, but I'm not a perfect square? 7, 11, 6, 5, whatever. All right? Well, I still have 2 real roots, but this time they would be irrational. Yeah, I should probably spell that correctly. They'd be 2 real irrational roots, which means my answers wouldn't be nice whole numbers or nice perfect fractions. Let me give you an example of what that might look like. Okay, parabolas open up and they open down, correct? So I'll give you an example of one opening down. Here's -1, here's -2, here's 1, here's 2. I might have a graph that goes like this. Okay, this might be -0.7834, etc., and go on forever, because that's irrational. That is irrational. This root right here might be 1.7365, etc., etc. It would go on forever. They wouldn't be nice, crisp numbers, I like to call them. They're crisp. They're crisp because I don't have to run after them forever. I don't know. I just made that up. I'm so sorry. Now, what happens if I do the discriminant here? I calculate it, and it doesn't turn out to be greater than 0. It actually equals 0. You want an example of what that is? There you go. Sorry, I'm just playing with you. Now, you wouldn't have 2 real roots. You would have 1 root. Okay? You would have 1 root. And that root would be rational. All right? It would be rational. I would have 1 real rational root. Now, some people like examples, and I gave you an example of what rational is. An example of irrational. Pi is irrational, okay? 2.783 ... It goes on forever. Those are irrational numbers, right? But if my discriminant equals 0, I would have 1 root, and it would be rational. Meaning, if I had a graph here, and here is 1, and here is 2, my graph might look like this. It might touch the x-axis only once at 1, and 1 is a rational number. Okay, 1 real root. But you should say to yourself, Visca, if this is a quadratic, the biggest term should be x squared, right? Shouldn't I have 2 solutions? You do have 2, yeah, 2 solutions. They both happen to be a positive 1 here. Meaning, if I were to factor this problem out, I would get x plus, yep. I would get x minus 1 times x minus 1 equals 0. And if I t-bone this and solved it, x would equal 1 here, and x would equal 1. Technically, you do have 2 roots. They're just the same answer. They're the same. So when I say, what's the answer to this? I don't want to hear 1 and 1. There's 1 solution. It's 1. It just happens twice, but it's the same number, 1. So really, you do have 2 roots, but they're equal. They're both the same, okay? So I know I've been drilling that into your head. If you have a problem and it's whatever the biggest exponent is, that's how many solutions you should have. Well, you say 1 and we should have 2. You do have 2. They just happen to be the same, so we just say it's 1. Now, this last problem, oh boy. What happens if my discriminant, oh, let's get the highlighter out again because, you know, it's cool. What happens if I get a discriminant and I calculate it out and it happens to be less than 0? I don't know, -3, -2.1783, blah, blah, blah. Any number that's negative. I have what we call imaginary roots. And I think that's supposed to be an A or an E. Who knows? I put an E there. Imaginary roots. Okay? Visca, you're going crazy. What the heck is an imaginary root? Purple! So, you like how I do that every time I use purple? I'm like, purple! Anyways. An imaginary root. Here's 1 again. Here's 2 again. Here's -1. Here's -2. My parabola, whether it opens up or down, would not touch this at all, the x-axis. So I might have a parabola that looks like this. It does not touch at all. So no x-intercepts. Again, you're like, Visca, what if I have x squared plus 8 equals 0? Shouldn't I be able to solve that and get 2 answers? No, you won't get two answers. Sometimes there are no solutions. If I subtract 8 from both sides, I'll get x squared equals negative 8. If I try to take the square root of a negative number, that's a no-no. That's what this gets you right here. Okay, that's a great explanation I just gave you for why we get imaginary numbers. Now, we will get to a point where we will handle negatives underneath the square root, and we will call those numbers imaginary numbers. That's where this comes in, the term imaginary roots, okay? Because they're not real. They're imaginary. So let's start this. Let's start practicing some of these problems right here. All right? Now we're going to actually do this, and hopefully it becomes more clear to you. All right? So I've got my A value, my B value, and my C value. Remember, the discriminant is B squared minus 4AC. Okay, so it's B squared minus 4 times A times C, which is negative 1. Okay, that's 4 minus, okay, a negative times a negative is going to give me a positive. 4 times 3 is 12, times 1 is 12. That's 16, okay? That's 16. Now, in your notes, you should be referring to this right here. Okay, not only is it bigger than 0, 16 is a perfect square. So I should have two real rational roots. So I come back here. The nature of the roots, there are two of them. They're real, and they're rational. Bam. That's all you're going to do for the next few problems on this chart. 3 more. So if you want to pause this and do those, go ahead. But just like everything we do with quadratics, make sure it's equal to 0 first. Go, because I'm about to start right now. I'm going to add 3 to both sides. And I should have 3x squared plus x plus 3 equals 0. All right, my A is 3, my B is 1, because it's a 1 there, and my C is 3. All right, B squared minus 4AC. That's 1 squared minus 4 times A, which is 3, times C, which is 3. Okay, that's 1 minus negative 4 times 3 is negative 12. Negative 12 times 3 is negative 36. That's negative 35. And if we look on our chart, anytime my discriminant is less than 0, I have 2, I guess I can say 2, imaginary roots. They're not real. Okay? And yes, imaginary numbers and roots come in pairs. You cannot have 1, you always have 2. So when I go back here, and I say imaginary roots, notice that's plural, you have 2 imaginary roots. Sorry, I should have stated that. But if this is multiple choice, and they ask you for the discriminant and say, well, what type of roots does this quadratic have? Are they 2 real rational? Are they 2 real irrational? Is there 1 root? Or are they imaginary? All right, there's only going to be 1 multiple choice that says imaginary. So whether it's 1 or 2, if your discriminant is negative, it's going to be imaginary. All right, next one. On to the next one. Oh, okay, I'm going to add 16 to both sides. And I've got x squared plus 8x plus 16 equals 0. Okay, very good, very good, very good. And my A is 1, my B is 8, and my C is 16. My discriminant, B squared minus 4AC. That's 8 squared minus 4 times A, which is 1, times 16. That's 64 minus a negative 4 times 1 is still negative 4. Negative 4 times 16 is, oh my God, 64. That actually equals 0. That means I have 1 real root. Or as you guys say, 2 of the same roots. But if this is multiple choice, it would say 1 real root. And last but not least at all, If I subtract 7x, I have x squared minus 7x minus 5. My a is 1. My b is negative 7. My c is negative 5. So if I put this into the discriminant, negative 7 squared minus 4 times a, which is 1, times c, which is minus 5. This is 49 minus, well, a negative times a negative is positive, 20, 69. That is positive, so I know there's going to be 2 real roots. But is that a perfect square? No, it is not. So my 2 real roots are going to be irrational. Boom, there you go. The next 2 challenge problems are going to be part of homework, so I'm not going to be going over those. We'll see you later for Unit 1, Lesson 9.